So when we are dividing, we just have to be very careful that we're not making mistakes because we're dealing with bigger numbers. So 92 times 2, we would figure out what that is. And it's 184. Now we subtract 220. We have to do all of our borrowing. So 220 minus 184. We do 6. This becomes an 11, 36. Now we bring down the 8, and then we say 368 divided by 92. And we might have to do some work over here, but eventually we're going to get to that it's 4, and 92 times 4 is 368, so there's no remainder. This is a prime factorization tree. And this means they're going to give us the number 180, and we're going to keep finding factors that go down and make the 180 turn into smaller numbers until we have all prime numbers in our factorization tree. So that's how we can remember when someone's asking for it, they're asking for a tree that goes down until we have all prime numbers. Once you get to a prime number, we circle it. So 180, we could use any number that goes into 180. You happen to choose 90 and 2. Then for 90, you chose 2 and 45. We could use 9 and 10. We can use whatever we want as long as it divides down. It's 100% fine. Then you chose 2 and 45, then you chose 5 and 9, and then you chose 3 and 3. Once we circle the number, oh, I didn't tell you this. So they will ask us what the prime factorization is. We are going to list all of these numbers that we circled. So we're going to list 2, 2, 3, 3, and 5. And when we list them least to greatest. And we can do commas, but what is more common is writing it like this. We write it like 2 times 2 times 3 times 3 times 5. Whatever has more than one multiple like this, we're going to write it as an exponent. So you're going to say 2 to the second power times 3 to the second power times 5. Now the cool way to check your answer is to do, in 6th grade you can use your calculator a lot, so that's awesome. Not for some stuff, but for this kind of stuff like checking your work, you absolutely can. You wouldn't be able to do it for this because we have to show all of our work. But for a prime factorization tree, what we're going to do is we're going to use our calculator to check our answer. So we're going to do 2 times 2 times 3 times 3 times 5. If we get 180, we did it right. If we do not get 180, we have to go back and figure out what we did in here that was not correct. Okay, just to review what a prime number is. A prime number is 2 factors only. So when we divide a number down that they give us, it only has 2 factors, 1 and itself. Everything has 1 as a factor, even 1, right? The factors of 1 are 1. So 1 is always going to be there. And if it's a prime number such as 5, it's only going to have 1 and itself. There's not going to be anything else that goes into it. If there is something else that goes into it, like a composite, like 9, that's what's called a composite number. And that means that it's not just 1 and 9, it's 1 and something, and it can have many factors, but it definitely will have more than 2 factors. That's how we know it's a composite. LCM stands for least common multiple, and that means when you count up by a number and then you count up by another number, the least common multiple is the number that is smallest that they share in common. So we already did the example 3, 5, and 15. So I wrote out my 3 and I counted up 3, 6, 9, 12, 15. I wrote out my 5 and I wrote the multiples, which means you're multiplying up, which means you're counting up by that number. So I listed 5, 10, 15, and then I did this one, 15. When I get my least common multiple, I circle it, and then that is what I put as my answer. The other thing is a greatest common factor. We call it GCF. And GCF means it's the greatest number that when you factor numbers, which means dividing, when you factor them out, like in our prime factorization tree, what are the common numbers, the greatest one that they share in common? So we use 16 and 100 as the example. I will use a different one. So we're just going to do 6 and 48. So I'm going to find out what the factors of 6 are. 1, then I ask myself, is 2 a factor? Yes. Is 3 a factor? Yes. Is 4 a factor? No. Is 5 a factor? No. Is 6 a factor? Yes. Then I'm going to do the same thing. This number is 48, but I only have to go up to 6 because I know that's the greatest number that I'm going to be able to use, because 6 has a factor that is greatest of 6. So I only have to see if 6 is my biggest number for 48. So I'm going to say, does 1 go into it? Yes. Does 2 go into it? Yes. Does 3 go into it? Seems like it doesn't, but I actually know it does. If you don't know, you actually have to divide it out, and you have to figure out, is it one of the factors? 3. And then now I know 3 and 16 are common numbers, because obviously 3 times 16 is 48. So I'm just going to put 16 here because I know that that's going to be one of my factors. Does that make sense to you?
Yeah.
Okay. Is 4 1? Yes, because I know 4 goes into 48 12 times. So I also know that 12 is going to be a factor. Is 5 a factor? No. Is 6 a factor? Yes, because I know 6 times 8 is 48. So I'm just going to go ahead and put 8 in there. And then I don't have to keep going because I'm just looking for my greatest common factor. So 6 would be my greatest common factor of 6 and 48.